Hello everyone, welcome to Codeforces round 987. We are solving problem C, Penchick and BBQ Buns. So in this problem, Penchick loves two things, square numbers and Hong Kong style barbecue buns. For his birthday, Kohan wants to combine team with a gift and BBQ buns arranged from left to right. There are 10 to power 6 available fillings BBQ buns, number from 1 to 10 to power 6. Ensure Penchik would love this gift. Kohan has a few goals. No filling is used exactly once, that is, each filling must either or not appear at all or appear at least twice. For any two buns I and j that have the same filling, the distance between them, which is absolute value of I minus j, must be a perfect square. Okay. Find the Kohan, help Kohan find a way to choose filling of the buns or determine it is impossible to satisfy the goals. If there are multiple solutions, print any one of them. Okay. So we in this problem we will be solving it for t test cases, and in each test case we'll be given an integer n, and it will range from 1 to 2 to power 5, and for each number we have to print n sized array, or if it is possible otherwise we have to return -1. The condition is that the distance between I and j, that the two same elements if they are occurring. So let's go to the editor. Let us say that the first condition says that no filling should be used exactly once. So I can't have this one appearing only one time in the array. If there is one, I should be having it one more time, at least two times, or we can have it multiple number of times, but at least it should not be just occurrence of one. Okay, either zero or more than one. Yeah. So in this case 2 and 3. So yeah, this makes sense for first condition. But in the second case it says that the absolute value of the indices of I and j where both the elements are equal should be a perfect square. Okay, so I can't place 1 because the difference in I and j is 1, 2, 3. So absolute the difference in the indices is 3. Same for 2, same for 3. So 3 is not a perfect square. So very first thought that comes to our mind is the just place the number immediately to its next. What will happen is that now different indices of 1 is 1, 2, that is difference is 1. So that is a perfect square of 1. Same for 2, same for 3. Okay, but this is only when my n is even. So we have cut down the problem that if I've taken this input and I have checked that if its modulus n is odd or even. If it is even, simply iterate it to n by 2, and for every I you just print it out from, and I is from 1 to n by 2, and print 2 times. So what this is doing, the difference adjacent is always 1, and that's a perfect square, so we don't need to care about. So yeah, this solves the problem. But now what about when this is odd? Okay, now the very first thought that comes to our mind is that how can we place it? Can we try it for 4? Let's see. So if I do it like 2, 3, 4, and now 1. So now difference between ones are 4. Makes sense? But now I have to find something to do it for 2 also. Again, you can say that why not just make it here 2? That sounds good. That 2 sounds good, but now this is even. I need one more element. I made it 3. This is working fine, but what about this 4? I can't you make use of only one time. Either have to remove it, but once I remove it, it will alter all the other positions and condition will be violated again. So I can't do that. One thing that came to my mind is I don't know how, let it Pythagoras theorem. 3 square of 3 square of 4 gives me square of 25. Okay, so what if I start placing my number? I was experimenting out with some numbers, that how can I place them in some particular order. That one thing we know, that when we have this in between elements as even, I can just place them adjacent, and my thing is done. Okay, so the thing I came to my mind is that if I have one placed here, now I can place it to a particular number, so the difference between both the number is 9. So instead I have 8 positions left. So let's put them with some value. uh, let's do 2, 3, 3, 3, 4, 4, 5, 5. this makes 1 2 3 4 5 6 7 8 9. So this solves my problem, that 1 2 3 4 5 6 7 8 9 10. So this sorts for, I'm just trying to build a proper uh, array that will satisfy both the conditions. Okay, just for experimenting out, I just wanted the very first number. So this is basically the first number, the first array that was being created by just experimenting out. I will come to it, that how we can further break it down. Next, 6 6 7 7 8 8 9 9 1 2 3 4 5 6 7 8 9. Okay, so this gives me 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Now my 16 is solved, but if I want to place my 1 here, then only this will be sorted. But now this is again an odd number, so I don't want it here. So what I'll do is I will put this number somewhere here, and now I place 13 back here. Now what is the question? The difference what is the distance between ones is the same distance between this 13 also. So the distance between one is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So 16, that is my, again, a perfect square. So this is sorted, this is sorted. Now I have to take in mind that this entire difference also should be sorted. So that is why I mentioned Pythagoras theorem, that I started first difference 9, another difference 16, and then combined difference makes it 25. So difference between this one and this one is 25. Now this thing is sorted. So but we need to calculate what is the total length. So total length of this is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 1 3 4 25 26 27. So this is 27. Now what about the next numbers? So here in this case I have to only deal with odd numbers. Okay, so another numbers will be 29 31 33 35. But what if I tell you that if I subtract 27 from them, because I have the fixed lot of 27, if I subtract 27 from 29, I'm left with 2, left with 4 when I subtract it from 31, left with 6 when I do it with 33, and 8 when I do it with 35. Now I can solve it for even number very easily, as we have done it for the else case. So that is a very now simple task to do. So this was the only main crux of this problem, because we have to figure out the smallest Pythagoras number with even stuff in them, so that I can place my 3 ones in proper order without altering the rules that we have, and all the odd numbers from 1 to 25, their answer will be -1. So yeah, this was the overall idea for this question, and this is how we have solved it. If you guys have any query, do comment it out, and if you like the video, give it a like and do subscribe for more daily content. Thank you.